Hi there, Mr. T here. I'm going to work on solving quadratic equations, and it says by taking square roots, but this is going to be part 2 of 3.1, where we're actually doing it by square roots, by graphing, and by factoring. Okay, but this is introducing this idea of imaginary numbers, and we're going to kind of get into that. But let's do a quick kind of review. Now, it says the essential question here, it says, what is an imaginary number right off the bat? And how is it useful in solving quadratic equations? Well, I would say let's solve quadratic equations. And by the way, sometimes we have imaginary numbers that can be useful. Okay. And I would turn that around just a little bit, but it's the same idea. That's what we're focusing on and looking at multiple different kind of ways. And but taking a little bit of a focus on what are imaginary numbers. Now, we did, first of all, solving by graphing. We reminded ourselves we would take our left side, we would graph um, that in our y1 of our calculator, and then the right side in y2, and see where they cross. And in this case, it was -4 and +4. Or we could solve it for 0, and it would still be -4 and +4, but it would just be where it crosses the x-axis at that time, because it would be x squared minus 16 at that point. But that's solving by graphing. And then we spent some time looking at solving by factoring. And we'd already spent some time reviewing factoring before now. And we talked about how you set up each factor equal to 0, still get the same answer. And then we talked about this whole square root thing. And if you're following along in our current textbook, it's page 113 there. And this is where you get it to where you have just the square term alone, and then you take the square root of both sides. And we got a nice easy plus or minus 4 at this point. Remember, when you take a square root inside of an equation, you have to do the plus or minus or else you wouldn't have it all. Okay. Oh, there's our third lunch bell, but that's okay. Then we spent some time. We'd already spent some time reviewing how to break it down radicals or square roots, and then just barely touched on this idea of rationalizing the denominator. And again, we mentioned that in the previous video. If you need more help than what you got here in the examples that we're going to go through, you're probably going to need to go look up how to rationalize the denominator. Okay, videos separately. Okay, if what you get out of this is just not quite enough. Okay, so here's what we did, solving by square roots. Here's an example. We just solved it like there wasn't a square in it, and you subtracted 9 from both sides and got this guy here. Then we divided both sides by -5. The negatives canceled. Then we took the square root, split the square root into the numerator and denominator, and then that gave us a 3 over the square root of 5. And well, we're not allowed to leave a square root in the denominator, so we had to rationalize it. So this is what's called rationalizing. Whatever's in the denominator, top times top, bottom times bottom, and then the square root of 25 turns into plain old 5. So we got the square root out. Made it a lot messier, really, but that's what we had to do. Collateral damage, sorry. So just a quick refresh. So that's kind of where we've been to this point. And that's kind of set us up for now to be looking at the couple of word problems using this idea. Now, in the homework practice problems, it talks about a squirrel and an acorn and a tree, but it shouldn't be that hard to go translate this, because our example here talks about dropping a water balloon from 4 foot off the ground, okay? And we're modeling by 16 t squared, so it has something to do with the gravity and how fast things fall, t being time and d being the distance. So we're taking 4 foot off the ground. How long is it going to take? So we take this formula, we plug the 4 in there, and then subtract, and we divide by 16 and work our way through there, okay? So that's our example. So in the practice problems, they just changed it from a water balloon to an acorn, and instead of 4 foot, 20 foot. So you would just have a 20 sitting here and work your way through that for those practice problems. And then the other one is this guy here. It's not going, so we're dropping it from the top of a building, again, a water balloon, and not going all the way down. Yes, it's going to go all the way to the ground, but we're not concerned about that. We're concerned about how long does it take to hit the 3rd floor, okay? Now, I think it'd be a more interesting story if this guy was like the big brother and his little sister was hanging her head out the 3rd floor story, and then he's trying to hit her head. How long would it take to splatter in the head? But so be it. They didn't do that. Okay. All right. So, but what we do have here is we got a 50-foot building. Okay, it's 5 stories, and they want to know how long does it take for it to hit the third story windows. To go past them. And so what they've done again, we got that 16t squared going on here. But I want you to take note of this h sub 0. That is what's called the initial height, sub 0. It's not first floor, second floor, third floor, whatever. It's the initial height. And we're coming to that again when we talk about geometric sequences and arithmetic sequences. A very similar notation is going to come in, except it would be like a sub 1, which means the first one, that kind of thing. All right. So that kind of ordeal there. So what they did is they said the initial height is 50. So there's where that 50 comes in. And then they want to know at the 24-foot mark. And then they went through and solved it and had to do some simplifying there. But that's how you set that up. That should help you with the problem in the book as well, or our practice problems. Now, when we're talking about solving by square roots, sometimes you end up getting a square root of a negative number. And in algebra 1, we just go like, you can't do that. That's not a real answer. Okay. But in algebra 2, we're going like, what are we going to do about that? So let's take just a second and talk about this. So this thought about 3 times 3 is positive 9. Therefore, the square root of 9 is plain old 3. Well, how about negative 3 times negative 3? Well, that's also positive 9. Okay. And so now we're pretending like this particular 9, it comes from here. So that means the square root is negative 3. So that's why we had that whole plus minus thing going on, because we don't know if it started off as positive or negative. So what if we have the square root of negative 9? Well, positive 3 and negative 3, they're already taken. What you going to do about that? So you can't say the square root of negative 9 is negative 3, because that don't make sense anyway. So what they did is they come up with this new little theory, and some people say, well, they just pulled that straight out of the air. And if it's not actually true, but it's close. It's all right. They just defined a new term. They said the square root of negative 1 is going to be called I. That's its definition. That's just its name. It's no great meaning behind it. That just is what it is. Don't try to think any more about it. Okay, so what they did got real fancy, and so all right, let's take the square root of negative 9. Is that the same thing as negative 1 times 9? Yes. Okay, let's break that apart into 2 different square roots. All right, and so this first one turns into an I, and the second one turns into 3, like we already knew. So we have the square root of negative 9 is just 3I. Okay, so I did a few more examples with that on this next page here to kind of bring this point home. Let me get my face out of the way up here. All right. And so there's the definition. So if the square root of 4 is 2, then the square root of negative 4 is 2I. If the square root of 25 is 5, then the square root of negative 25 is just 5I. If the square root of 50 is 5 on the square root of 2, well, then the square root of negative 50 is 5I on the square root of 2. Same thing with 18 there. Okay, it's just basically you put an I with it, do it like you would normally. Don't get overly uptight about it. Okay, so that's I for you. And that is its definition. But what happens if you square it? What happens if you square it? Well, let's think about that. And I forgot to put that slide in here. So what would I squared be? So let's slide back here real quick to this guy here. So if this is I, right? Well, what is I squared going to be then? Well, let's think about that. Let's I squared would be equal to the square root of negative 1 squared, right? Well, the square root and the square cancel. That leaves you just negative 1. So what we're trying to say here is this, is that I squared equals negative 1. So anytime we see an I squared, we can put negative 1 there, which causes some interesting things to happen. All right, so that's where these examples are kicking in at this point. So what if we take 5I and square it? Well, that's the same thing as 5 squared and I squared. which is 25. We just said I squared is -1, so it gives me -25. We squared the original 5i. What about these guys? Well, something I want to give you a hint about. If you get a negative I on something, what you want to do is you want to slide that over here because that's a legal thing to do, right? We can make that over here. Just think about this because you could have, let's just say, for instance, we had negative x times 3. Could you not just say that is -3 times x? Wouldn't that be legal to do? That's very much the same thing we're going to be doing here. So you see how this negative is getting pulled over here because it's a little bit more challenging when you leave it with the I. So, so here we go, negative square root of 2. So negative times negative is positive, and the square root and the square cancel, leaving you just plain 2. And then I squared is -1, and that brings you to -2. So when you have a negative on the I, pull it over here with the other number and leave the I separate like that. It makes it easier to work with. And then they got this other reflecting concept there that you can read if you like to. Now, the next thing here, it says your turn. So if you could stop the video and give this a shot, that would be really good. Okay, so why don't you do that right now and then put it back on and see if you get what I get. Okay, now you're back. Let's see how this worked out. So we're going to square this, right? So basically this is -2 squared and then I squared. Now I'm going to remind you, if you're using a graphing calculator, you better put the parentheses around that or else it's going to square the 2 and then put the negative on it. Because we know that -2 squared is just plain old 4, right? Hopefully we know that. And then that's -1 and that turns into -4. Hopefully that is what you got when you tried it on your own. All right, now let's got this guy. I'm going to square it. So I'm going to make it easier to do it this way. Let's do square root of -3 squared over 3 squared times I squared. Just do, that's a legal thing to do. So with square root and a square, leaves me with just plain old 3. 3 squared is 9 times what? -1. That's 1/3 times -1 gives me -1/3. Okay, hopefully that's what you got when you tried it on your own. And so that's kind of the deal there. Gives you just a little bit of practice. We're going to do more of this in the next section. So if you're kind of still with this, that's okay. We're just getting you started in the right direction. We're going to do some more in our next section. Right now, this is mostly all we need to get you through, okay? At this point, you're solving this equation by square roots. So we subtracted the 12. But then when you try to take the square root of a negative, what's going to happen to that negative? Well, it's going to turn into I, right? And then you attack the 12 like you would otherwise by breaking it into 4 times 3. The 4 turns into plain old 2. And you get 2i on the square root of 3. Of course, you got your plus minus in front of that, okay? So the big thing that you're catching from this really is what? The negative. Just pull that out and make it an I and then deal with it like you would normal, okay? There's some more things. Again, we're going to deal with that some more. But for the moment, that's the biggest thing you need to worry about in this section. So that's part 2 of 3.1. Hope that's helpful. I'm going to jump into some more stuff with quadratics, quadratic formula, and adding, subtracting with these imaginary numbers in the next couple of sections. Hope to see you there. But if you have any questions, let me know. Bye.